And we'll explain this with recourse to our previously made table, if you'll remember. Eventually I'll bring this up and make it better. So when you have an implication, such as this one, so like the first, the second, we're saying that we can transform this into this by denying or by negating the first variable. So effectively, this expression is transformed into so an equivalence expression is transformed into a disjunction expression by negating the variable, the implicator variable. So this is the implicator variable, and we're negating it, and we're obtaining a disjunction. So I'm explaining this in this format, so you can learn to deduce these things as well. It's part of the learning, not only the learning process, but being able to deduce things is fundamental. So let's see. So we're getting this, right? From this, the only thing is we're negating the first variable. So what happens when we negate the first variable in this scenario? So we negate 0, we get 1. When we get 1, given this implication, right, when we have this case, this scenario. So if we're negating the first the first option, then we can simply, instead of rethinking the whole logic, we can transfer our thought to this line in the table and simply observe that what happens is that this becomes 0, right? So negating this won't be the same. However, if we look at this column instead, so we're explaining why this can be represented by the negation of x disjunction y by placing our thoughts from this table, looking at the initial part, seeing how it causes 1, right? So yeah, then we go back. This one begins here, and we negate x, making it so that x, which is 0, becomes 1. And then if we follow this path, we'll see that, right, if we negated x, we would have 1, and the result would be 0. However, instead of the implication, we place a disjunction, and what is the value that we obtain? It is 1. So I hope you followed along. I tried different approaches here, but yeah. So this is proof of conversion. You can always write this is called a truth table, by the way. This is a truth table, this is a truth table. Yeah, they're all truth tables. So right now, we can at least verify the outcome. Now let's move on to the proof. So this one is quite hard. Let's call it the So this one is easy difficulty. This one is medium or average. The one after, I don't want to spoil it for you, but it will be the level after, which is hard. But I'll try to keep it simple. So before we prove this, now don't skip this because this is important. However, I made a mistake here, a slight mistake based on the manual that I'm reading and learning from. In fact, by thinking by myself, I've concluded that this is not exactly a property. So it is a great exercise of the mind. This is a property, right? It's been mentioned. This is a good exercise of the mind, and the way this works is essentially to explain, in fact, a property that is implicit in it. So we have the equivalence, and we have the disjunction, and we have the negation, and we have both these variables. Converting this expression, so like to say that they're equivalent means that, means that the result, so the value, the total value, and this total value, they're exactly the same. So whichever input they receive, they output exactly the same. So if this guy received as inputs 1 and 1, and this guy received and this guy received the outputs 1 and 1, and if this was the input, that was the input, the output, let's say it would be 0 and 1, it would have to be true, right? That in this case, the output would have to be the same, 0 and 1. That said, how do we reach this conclusion? Okay, so we use the truth tables. Yes, we use the truth tables. It sounds, from a pessimistic standpoint, it sounds way more trickier because it involves deducing things on another level. However, if someone asks you to prove these, you can make use of various strategies, and you have to really think about them. Like, you can think about making a Venn diagram, thinking of the first one as a phi and the one as a psi, and by exclusion saying that, oh, if I cancel this, then this part will be less, so the disjunction will be only this, so it will be solely dependent on that one. But that would be only one scenario, and there is a much easier way of seeing things than making diagrams. You can go back to the truth tables, right? And I'll do an extra. I'll bring this along to explain it, if I can. Just make sure that. Stop battling me. Okay. And we go back to the truth table section. Okay. Bring this down, maybe underline it a little bit so that we can like focus on it a bit better in the face of so much visual stimuli. Some people work like that. I am one of those, so yeah. Things have to be straightened out. Okay, so the basic idea here is, let me center this on one plane that includes them both. is we'll look at the first expression and we'll look at the second expression, right? And we're saying that it's equivalent. But well, how do you prove that? We prove that by inspecting the outputs. So